Hello everyone, welcome back to another video. And today we're going to be deviating from the normal type of videos that I make here. We're not going to be solving a leak code style question. We are going to be going over the basic data structures in Python. And I believe this is really important because let's just go to the roadmap here, the Neat Code 150 roadmap, and go to arrays and hashing. And if you look here, there's prerequisites. So you see prerequisites for arrays and hashing, dynamic arrays, hash usage, hash implementations, and prefix sums. So that means before you should even think about attempting these problems, you should know these things. And I think we need, so to even think about starting leak code or the Neat Code 150, you should have a really good understanding of the basic data structures in Python. You should have an amazing grasp, like the back of your hand. You should know what you're doing. And here I made a flow chart, or not flow chart, but like a chart, I guess, of the basic data structures in Python that are built in. So all these abstract data structures you see here in the roadmap, like tries, graphs, heaps, priority queues, stacks, linked lists, are built off these core data structures right here. These ones right here in this that I have. Hold on, let me do this real quick. All these. So before you even think about implementing those, you gotta have a really good understanding of these. So that's what we're going over in today's video. So let's get started. So let's start with lists. So a list is the most common and flexible data structure in Python. So a list isn't basically an ordered, mutable collection. It can be a collection of anything, integer strings. It can be a collection of multiple types. So what does ordered mean? So ordered. So obviously ordered means that the items maintain the same sequence in which you insert them. So let's say here we have an empty array here. So let's insert 1. Then you can insert 2 and 3. So now this array will maintain this order that you inserted by 1, 2, and 3. It won't be random or anything. So another thing with lists are they're mutable. That means you can change the list, you can add, remove, or modify elements any time. So let's go over here to the interpreter to get a better understanding of this. So here we have an array of fruits, array of strings, apple, banana, and cherry. So now what can we do here? So first, when you add something or initialize an array with elements, they all get a unique position, and that position is their index. So let's go back to the diagram here. So you can see 1, 2, and 3. So 1 would be index 0. So the first element in every array or list is index 0. Remember that. It's not 1, it's 0. And that's just how it is. And then the second one would be 2 would be 1, index 1, and 3 would be index 2. So just, you probably know that already, just making sure I'm not throwing something at you don't know. So now let's give you an example here of using the index. So let's just print the first value of the array. So let's print fruits at 0. Print that, you should get the first element, which is apple here. So print that, yep, you get apple. And let's show you how it's mutable. So I said mutable means you can change the list, add, remove, or modify. So let's add. So the way to add to a list in Python is append. Fruits.append. And let's include fruit to add. We can add mango, because why not? So now this will add mango, and append will by default add mango at the end. So the last element should be mango now, not cherry. So if we print fruits now, we should get mango at the end. Yep, you see right there, mango. So now Obviously, there's other functions that I won't get into, but there's a append function. Well, we just did the append function. There's an insert function, remove, and sort. Well, we can go over the sort function. So, well, it's actually sorted, but so yeah, remove is basically self-explanatory. It can delete a value, insert. You can add a value at a specific index. So append adds to the end. What if you wanna add a specific value at a specific index? So there is an append function for that. I won't go over that right now. That's pretty simple to visualize. And now let's go over the sort. So usually when you call a sort function, see this is a list of strings. If you call it on a list of integers, you can imagine what would happen. It would, I believe by default, it would sort them from ascending order, so the smallest number to the biggest. So what would it do for a list of strings like we have here? So let's call it the sorted. The sorted would return the sorted list right directly back to us. So the sorted fruits. So this would actually sort the string or the array of strings lexicographically. And what does lexicographically mean? Basically alphabetically. So we can see here. Actually didn't really change because it actually, so let's switch this around. Let's put apple here and banana here to show how it does this. If we run this now, yep. See, this is the original string, original array of strings, and now we sorted it, and now it's all in lexicographic order or ABC order. So yeah, that is really on lists, but let's see what am I forgetting anything else. A list can actually, already went over this, a list can hold multiple data types. So you can have number of strings or even other lists inside a list. So that flexibility is pretty good for quick prototyping, but usually in performance heavy code, you want consistent types in your list. It's just something you should remember. So now, I mean, I guess what I should really go over now, the last thing, is when should you use a list? So you should really use a list when you need an ordered collection that can grow or shrink. So perfect for things like use your data, to-do items, or like sequential processing tasks. So that is really it for the lists. Now let's go to the next one, tuples. So I'm not really gonna take too long on this because tuples are like lists basically, but there's one major difference. They're immutable. So remember, mutable meant we could change and modify it. This might sound restrictive. Mutable means you can't modify its contents of a tuple. It's immutable. So obviously at first that might sound pretty restrictive. Like why would I use a tuple? I'd just rather use a list instead. But the immutability actually has benefits. It makes your data safer and faster to access actually. So tuples are stored more compactly in memory, and Python can optimize their access since they can't change. They're also hashable, meaning that you can use tuples as keys in dictionaries or elements in sets. And as you can see, your dictionary and sets are other two. We'll go over that later in the video, but I'll understand what that means later. And you also can't do that with lists. Like a list can't be a key in dictionary, so or an element in a set. That's also another advantage for tuples. And you can unpack tuples easily as well. So now the big question is, when would you use tuples? If you're still not convinced, here is my explanation. So when your data represents something fixed, that's when you should use a tuple. Like a coordinate pair or a database record or configuration values that shouldn't be changing at your code's runtime. So think of tuples as a read-only list that prioritize data integrity and speed. So that's really it for the tuple. And now on to the dictionary. So now this is really important, a dictionary. So one of Python's most powerful and beloved structures. It's also known in Python as really just dict, just short for dictionary. So a dictionary stores key value pairs. It's like a mini database inside a program. So each key acts as a unique identifier for a value. So let's go here to ID to really like visualize this, because obviously the best way to learn is to actually go and code it. So let's make a hash map. Sorry, not hash map. I just habit of saying that. A dictionary. It's called student. So now student, and obviously you would initialize. So maybe tell you how to initialize an empty dictionary. You just the name of your dictionary and then empty curly braces. That's how you would initialize an empty dictionary with curly braces. So now let's have, remember, key value pair. So let's create one right now. So you can have our key as strings, name. This will be our key name. And what is my name? My name's Baruch. Also a string. Let's keep this in a string. And then now what is, let's say my age as another key. What is my age? I'm 19. And then let's have my major. Just keep it simple. Major as a key, and then the value of major. What am I? So major CS. That's my major. Just keep it short. So now, let's print a value. So how do you print a value? So let's say we want to know my name. So how do you print my name from the dictionary? So you would just say the name of the dictionary, which is student in this scenario, and then square brackets and the key. So the key's value, if you want to return the key's value, you should just say key you want. So let's just say you want my name, just put name. So now this should print my name. Oh, sorry, I didn't specify. That's kind of stupid on my part. The string, remember that. Just remember that. So, yep, there you go. See, my name is printed there. And now we can also modify a dictionary. So let's change my age, for example. So student, so remember we want to access my age. So we use the key age. Age. Keep making the same mistake. And then let's say my age is 20 now. Change to 20. And now we can also print the entire dictionary out for us. So to see this change. So let's just print student. Let's run that. As you can see, it printed out the whole dictionary. And my age is now 20. So under the hood, dictionaries are implemented using hash tables. So why is this useful? So it's good for lookups, insertions, and deletions. That makes lookups, insertions, and deletions really fast. Typically, constant time actually, big O of 1 on average, which is amazing for problem solving. So there's also key things to remember here in a dictionary. So let's have a dictionary. So keys have to be immutable. So remember, back to the tuple, going back to the tuples, that's why tuples are good, why you should use them. That's another use for tuples. Keys have to be immutable. That means strings, numbers, or tuples work fine for keys, for the key. Like a list would not work because it's mutable. So now that's about the keys. Now to the values. So values can be anything actually. It doesn't matter. It's just the keys that really have a restriction. Values can be anything. Lists, actually, values could be other dictionaries or even functions. So now let's go over how you can loop through a dictionary. So let's go over here. Let's delete this for now. So how can you loop through a dictionary? So there's actually many ways you can loop the dictionary, but I'm just going to show you a common way. So for key value, those variable names, So now this would be the key, and this will store the value in the dictionary. And then in student, and this is where you would call items. So that would help us iterate through everything in the dictionary. So now let's go here, and then we can print. Let's say I want to print the whole thing. Let's print our key. And then our value. Just do there. Let's go here. Yep, there you go. That prints in a more better, like, that format looks better. But that's just how you loop through. So dictionaries are really versatile. So you can use them for things like storing configuration settings, counting word frequencies, which would appear a lot in LeetCode if you watched my previous videos, mapping IDs to objects, or working with like JSON data from APIs. So, well, actually, in fact, when you parse JSON in Python, it'll automatically become a dictionary. So dictionaries are really useful for everyday developing or programming. So now, let's answer the question for this data structure, when to use a dictionary. So I did list a lot of reasons, but here is a simple answer. So whenever you need to store relationships between pieces of data, where each piece has a name or label you can use to access it. So that's basically when you would use a dictionary. So let's go back here. Now back to this, and now we're on to our last basic data structure, a set. So now finally let's talk about sets. So what is a set? A set is an unordered collection of unique elements. Unordered. It automatically removes duplicates, which that's what a set does, which makes it super useful when you want to eliminate repetition or perform mathematical operations like union and intersection. So no duplicates in a set, remember that. And it's also unordered. So remember, a list is ordered, it has indexes. A set does not keep track of that. Like, think of it like a bag of numbers. Like if you have a set of integers, just think of it like a bag of numbers. There's no order at all. There's no index. So let's say, let's initialize a set. So let's say numbers. And if you want to initialize a set, it's also with curly braces, like a dictionary, but it's just the format of what you write in it is way different than dictionary, obviously. So now we just write like a normal list. So let's just say 1, 2, 3, and let's add a duplicate here, 3 and 4. So now we have a duplicate in the set. Let's see what happens when we try to print the set. So let's print numbers. And now remember, I said a set removes duplicates, which is really useful. That's a really useful thing you should remember about sets. So if we print this, it will remove the duplicate 3. It'll only have 1 3, only unique elements in a set. Remember that. So you're also probably wondering, like, yeah, as I said, curly braces, like a dictionary. That's also because sets are built on hash tables, just like dictionaries, but they only store keys, not key value pairs. So that also gives you very fast, like, membership testing, like in constant time, basically. So let's print this. So let's look at the set. So we want to check if 2 is in the set. The thing is, if you want to do this in a list, if you want to check if a number's in a list of numbers, that will take longer because you would have to loop through the entire list because it's an ordered set of elements. A set, remember, is just a bag. Think about it as a bag. So see this numbers right here? Think of it as just a bag of these numbers, and there's no duplicates. So checking if something is in a set is way faster. So let's just say print 2 in numbers. So this will return a Boolean value, and 2 is obviously in it, so it should return true. As you can see here, return true. So that's another thing to remember. And Python also supports full set algebra. So let's show you that here. Just make two sets here. It's just 1, 2, 3. This set, and let's make another set B. Let's just say 3, 4, 5, 6. Just finish the order. Just 3, 4, 5. Sorry, and then now let's start it. Full set algebra. So now we can do union. So what would union do? Union would just join these two sets and remove duplicates. That's what union will basically do. So if we do, so the way to do union is this. Wait, this is how you do union. So now, what would this return? This would just return 1, 2, 3, 4, 5. It would remove the common elements. Just merge them like that. See, and now we can do intersection. So intersection would be what two elements do these sets have that are the same. So it would only return that. So let's do this, and we do that with the and symbol and D. So what would this return? What are the two common elements in these sets? 3. So it would just print 3. As you can see here. Now let's do one more. We can do difference. So what is the difference? So let's do print. Here, yep, 1 and 2 as expected. So now let's answer the question for sets. When would you use a set? So you would use a set whenever you need to ensure uniqueness, compare groups of items, or check whether something exists in a collection like really fast. For example, if you're working with user IDs, product tags, or word lists, sets make these checks instant and clean. So, I mean, that's really it. So each structure obviously has its own strengths. Lists are flexible, tuples are reliable, dictionaries are really powerful, and sets are really efficient. So understanding how and when to use them makes your Python code not only cleaner, but also faster and more memory efficient. And that's what you really try to aim for when solving neat code or LeetCode problems: efficiency and like clean code, really good time complexity. That's all you should aim for, optimizing your solutions. And yeah, that's it. That's a complete breakdown of Python's built-in data structures. So I hope this helped you guys, and I'll see you in the next one.